No mathematical idea has ever been published in the way it was discovered. Techniques have been developed and are used, if a problem has been solved, to turn the solution procedure upside down, or if it is a larger complex of statements and theories, to turn definitions into propositions, and propositions into definitions, the hot invention into icy beauty. This then, if it has affected teaching matter, is the didactical inversion, which as it happens may be antididactical. Rather than behaving antididactically, one should recognize that the learner is entitled to recapitulate in a fashion of mankind. Not in the trivial matter of an abridged version, but equally we cannot require the new generation to start at the point where their predecessors left off. p9. Hans Freudenthal (1905–1990) was a German-born Dutch mathematician renowned for his significant contributions across various fields. In pure mathematics, he made substantial advancements in algebraic topology, including the introduction of the concept of ends of topological spaces, the Freudenthal spectral theorem, and the Freudenthal suspension theorem. He also developed the Freudenthal magic square in Lie algebra. Beyond his mathematical research, Freudenthal was a prominent figure in mathematics education. He founded the Institute for the Development of Mathematical Education, now the Freudenthal Institute, and championed realistic mathematics education (RME), an approach that emphasizes learning mathematics through real-world problems and student rediscovery. He was also known for his work on Linkos, a constructed language designed for communication with extraterrestrial intelligence. Hans Freudenthal's early life, beginning with his birth in Luckenwalde, Brandenburg, Germany, on September 17, 1905, laid the foundation for his remarkably diverse intellectual pursuits. Born the son of a Jewish teacher, he displayed a keen interest in both mathematics and literature from a young age. This dual fascination would remain a defining characteristic of his career. In 1923, Freudenthal enrolled at the University of Berlin to study mathematics and physics. This period was crucial for his intellectual development, as he was exposed to prominent mathematicians of the time, including Heinz Hopf, who would become his doctoral advisor. His early studies also brought him into contact with L.E.J. Brouwer, the renowned Dutch intuitionist, a meeting that profoundly influenced the direction of his later career and ultimately led him to the Netherlands. He spent a summer semester in Paris in 1927, further broadening his academic horizons. In 1930, he completed his doctoral thesis on the ends of topological spaces, demonstrating his early prowess in algebraic topology. This solid grounding in rigorous mathematics, coupled with his expansive cultural and literary interests, set the stage for a life of profound contributions to both pure mathematics and its broader applications, including his innovative work on the linguistic aspects of interspecies communication. Über die Enden topologischer Räume und Gruppen 1931. This foundational paper, published in Mathematische Zeitschrift, marks one of Freudenthal's earliest and most impactful contributions to algebraic topology. In it, he introduced the concept of ends of a topological space and of a group. Essentially, the ends describe the different ways one can go to infinity within a given space or group. Imagine walking away from a central point. Depending on the shape of the space, you might have one direction to go like a line, or multiple distinct directions like a graph with several infinitely long arms. Freudenthal's work provided a rigorous mathematical framework for classifying these directions to infinity, which has since found widespread application in group theory, geometric topology, and the study of infinite graphs, offering deep insights into the global structure of these mathematical objects. Teelwijs Jordanet Module 1936. Published in the Proceedings of the Royal Netherlands Academy of Arts and Sciences, this paper delved into partially ordered modules. In abstract algebra, A module is a generalization of the concept of a vector space, and a partial order means that while some elements can be compared, one is greater than or less than another, others might not be directly comparable. Freudenthal's work here was crucial for developing what is now known as the Freudenthal spectral theorem. This theorem is a significant result in functional analysis, particularly in the theory of Rie's spaces vector lattices, providing a way to represent certain operators in terms of integrals. This abstract work laid important groundwork for later developments in analysis and operator theory. Über die Klassen der Sphärenbildungen. I Großdimensionen 1937. This work, appearing in Compositio Mathematica, is another cornerstone of Freudenthal's contributions to algebraic topology, specifically focusing on mappings between spheres. Spheres of different dimensions are fundamental objects in topology, and understanding how one can map or transform one sphere onto another is key to classifying topological spaces. In this paper, Freudenthal established what is now known as the Freudenthal suspension theorem. This powerful theorem describes a relationship between homotopy groups of spheres which classify these mappings in different dimensions. Roughly speaking, it states that suspending a sphere creating a higher dimensional sphere from a lower one by stretching it stabilizes the homotopy groups after a certain dimension. This theorem was a landmark achievement, profoundly influencing the development of stable homotopy theory and remaining a vital tool in algebraic topology. Linkos, Design of a Language for Cosmic Intercourse 1960. Perhaps one of Freudenthal's most imaginative and interdisciplinary endeavors, Linkos, Design of a Language for Cosmic Intercourse presents his ambitious project to create a constructed language for communication with extraterrestrial intelligence. Published as part of the Studies in Logic and the Foundations of Mathematics, Linkos, short for Lingua Cosmica, was designed to be understood by any rational being, regardless of their biology or culture. Freudenthal meticulously constructed the language from fundamental mathematical and logical concepts, progressively introducing more complex ideas like time, behavior, and even moral concepts, with the aim that an alien civilization could decipher it through logical inference. This work stands as a unique blend of mathematics, logic, philosophy of language, and speculative communication theory, grappling with profound questions about the universality of reason and the possibility of interspecies understanding. Linear Lie Groups 1969, with H. de Vries. Co-authored with H. de Vries, Linear Lie Groups is a comprehensive textbook that cemented Freudenthal's expertise in Lie theory. Lie groups are smooth manifolds that are also groups, and they are fundamental in many areas of mathematics and physics, including differential geometry, quantum mechanics, and particle physics. This book provided a detailed and rigorous treatment of linear Lie groups, which are Lie groups whose elements are matrices. It served as a vital resource for advanced students and researchers, bringing together complex concepts from algebra, geometry, and analysis. The work reflects Freudenthal's deep understanding and significant contributions to the theory of Lie algebras, including the famous Freudenthal magic square, which relates various exceptional Lie algebras. Mathematics as an Educational Task 1972. This influential book highlights Freudenthal's deep commitment to mathematics education reform. In Mathematics as an Educational Task, he articulated his philosophy, which would later become the cornerstone of realistic mathematics education (RME). He argued against a purely formal or abstract approach to teaching mathematics, advocating instead for mathematics to be seen as a human activity, rooted in real-world phenomena and problems. The book emphasized the importance of students reinventing mathematical concepts through guided discovery, starting from contexts that are experientially real to them. This pedagogical approach shifted the focus from merely transmitting mathematical knowledge to fostering mathematical thinking and problem-solving skills, profoundly impacting curriculum development and teaching practices worldwide. Didactical Phenomenology of Mathematical Structures 1986. Following up on his educational philosophy, Didactical Phenomenology of Mathematical Structures delves deeper into the theory behind realistic mathematics education (RME). In this book, Freudenthal explored what he called didactical phenomenology, which involves analyzing mathematical concepts from the perspective of their origins and applications in various phenomena. The goal was to identify the rich, intuitive contexts from which mathematical structures arise, thereby providing a basis for designing effective learning trajectories. He argued that understanding the phenomenology of a mathematical concept, how it appears and functions in different situations, is crucial for teachers to guide students toward a deep and meaningful understanding, rather than just rote learning. This work solidified his legacy as a leading voice in mathematics education research. Revisiting Mathematics Education, China Lectures 1991. Published posthumously, Revisiting Mathematics Education, China Lectures compiles a series of lectures Freudenthal delivered in China, offering further insights into his evolving thoughts on mathematics education. These lectures reiterated and expanded upon his core ideas, emphasizing the global relevance and applicability of his realistic mathematics education (RME) principles. The book reflects his ongoing dedication to improving how mathematics is taught and learned, stressing the importance of making mathematics accessible, meaningful, and engaging for all students by connecting it to their experiences and fostering their active participation in the learning process. It serves as a distillation of his lifelong commitment to linking mathematical theory with practical pedagogical approaches. El Viaje de Ofentito 2015, with Matthias Freudenthal. This unique publication, El Viaje de Ofentito Ofentito's Journey, reveals a more personal and literary side of Hans Freudenthal. It's a children's story that he began writing in 1943 but left unfinished. Decades later, his son, Matthias Freudenthal, completed and translated it into Spanish, resulting in its publication in 2015. While seemingly a departure from his academic works, this story reflects Freudenthal's broader intellectual curiosity and perhaps his belief in the power of narrative and imagination, even for complex ideas. Its completion by his son also adds a touching layer of family collaboration and legacy to his diverse bibliography. Hans Freudenthal passed away on October 13, 1990, in Utrecht, Netherlands. His death marked the end of a prolific career that spanned pure mathematics, mathematics education, and even the theoretical design of a language for cosmic communication. He left behind a legacy of profound intellectual contributions and a lasting impact on how mathematics is understood and taught. In appearance and behavior, Norbert Wiener was a Baroque figure, short, rotund, and myopic, combining these and many qualities in extreme degree. His conversation was a curious mixture of pomposity and wantonness. He was a poor listener. His self-praise was playful, convincing and never offensive. He spoke many languages but was not easy to understand in any of them. He was a famously bad lecturer. Hans Freudenthal. The case of methodology is analogous though less clear. Nobody would object to the subject of methodology being science, or some pseudo-science. On closer inspection, however, this agreement is no more than a verbal coincidence. It rests on what is meant by science, as reported as a subject of methodology. In fact, the subject methodologists call science is more often than not different from what scientists call science. Methodologists are inclined to consider a science as a linguistic system, whereas the scientist would only admit that his science has a language, not that it is a language. P1. References. Baez, John C. 2002, The Octonians, Bulletin of the American Mathematical Society, 39 to 145 to 205, AR14 Math 01051555V4, doi 10.1090 S0273-0979-01-00934X, MR188, 6087, S2 SID 586512. Beckers, Danny February 5, 2019. Why to publish on mathematics education so as to be useful educational studies in mathematics and its founder Hans Freudenthal. Educational Studies in Mathematics. 101, 7-17. doi 10.1007 S10649-019-9881-4. ISSN 1573-0816. Gardner, Martin December 1979, Mathematical Games, A Pride of Problems, including one that is virtually impossible, Scientific American, 241, 22-30, doi 10.1038 Scientific American 0979-22. DeVito, Carl L. 1992, Languages, Science and the Search for Extraterrestrial Intelligence, Leonardo, 25-1, 13-16, doi 10.230715756113, Jaster 157-5613, S2 SID 61246383. Narobs, Louis, Freudenthal, Hans 1973, Review, Hans Freudenthal, Linkos. Design of a Language for Cosmic Intercourse. Part I, Journal of Symbolic Logic, 38-3, 517, doi 10.23072273, 3050, Jaster 227, 3050, S2 SID 1188296552. Gravemeyer, K. Tierwell, J. 2000, Hans Freudenthal, A Mathematician on Didactics and Curriculum Theory, Journal of Curriculum Studies, 32-6, 777-796, doi 10.10800022027005016717, S2 SID 55632373.